Okay, hi and welcome to Notes 8.7. We just left part 2 where you got to see the Desmos working with the sliders on the exponential functions where we really got to dig into a little bit of how the vertex form moves. Again, it's more the understanding of the movement. We'll sketch from it, but we're not going to graph having you adjust the points that way with the patterns and stuff. Again, base 2, maybe anything other than that, we'll see. But really what we're going to do is we're going to use vertex form to kind of highlight how it moves and draw sketches. Because more often than not for the exponential function, if I'm asking you to graph, I'll have you make a table of values. But if we're doing it quickly in class, we're going to sketch. And the vertex form is pretty useful for us for that purpose, just to kind of get a nice visual of it. So with that being said, let's go ahead and get right down to it. All right, so looking here, this is what part 2 was. So let's scroll down here. And part 3 really is just us answering some questions in full-fledged vertex form. Again, what we'll do is we'll talk about the movements of it. We'll sketch one, and then we'll just kind of look at them in general. We'll keep this relatively quick. Okay, just to recall, this is our parent function and the pattern that we're going to be working with for some of these ones here, but you'll notice that some of the examples will change the base, and we'll talk about that when we get there. With that being said, and having our pattern done with that, this is kind of how a sketch would go. So looking at this one here, we know that any values up here in with the x is your h value. And remember, it was reversed. So it moves, and I'll just scroll down here for a second. It's supposed to be negative, so if it's positive, it's actually moving to the left, and if it's negative, it's moving to the right. Remember, it looks opposite in there. So if we look at this, this is really telling us that we're moving left 1. Okay, and then the value on the outside of the x that's being added to the whole function is the value of k, which is telling us to move up 3. And let's not forget that our base here is a positive value, meaning that it's not, well, it's a positive value, it's not a decimal, shall we say. It's greater than 1, so it means that it's increasing. Any values in the decimal range, if we recall from our card story activity, we kind of hinted at, are going to be decreasing functions or a decay, as we'll say. So this one happens to be increasing. All right, so now that we have that down, we know what this one looks like. We know that it goes through, and again, kind of talked about in the video of part 2 with the Desmos, is that's kind of your vertex, right? It's your y-intercept, where you want to start from. And we know that this one generally starts somewhere close to 0, 0 being the asymptote, but we can't cross, and we know that it curves up here, and we can do a pretty good job of sketching this function. So that's your parent function here. Don't get confused, I just did this one. Let's do this new function. I'll even change my color real quick. We'll use an ugly green here. But it says that we're going to go left 1. So we're going to move this point left 1, but we're going to go up 3. 1, 2, 3. And so there's our vertex in this scenario. So if we duplicate what happened in the first one, we came 1 point really slowly. We increased over 1 y value to our y-intercept. So that means that we'll start right here, and we'll increase really slowly until we get to our y-intercept. And then we're going to turn up pretty quickly. And we're going to intersect 6 because that would kind of match our point here. And then we're going to go ahead and intersect up here at 8. That should be our other point. But that would be where it is. And we actually did a much better job than just a sketch there. But you can see that we didn't need any table values to do that. And that's okay. With a base 2, you can probably do this a little more accurately. With a base 3, possibly 0.5 or a half as a base, you might be able to. But anything other than that, you won't be able to use this any more than just kind of an idea of where it went. The main point is we know that it's here, not here, which is a big deal. I mean, when we look at that visually, we can get a lot of information, even though it's not 100% accurate. So with that being said, let me switch back to my normal color, and let's see if we can just read through these and see what's going on with their movements. So if we look at this function here, 3 times the base of 2 raised to the exponent of x minus 1, all subtracted by 5, right? We know 1, that our base of 2 tells us that it's increasing. We know this value inside with the x, right, is a negative, so it's actually telling us to go opposite, which is to the right 1. We know that this subtract 5 here is moving down, so that's actually a subtraction of 5, so we move down 5. But let's talk about this 3 here. This 3 is taking all of these values that came from our parent function, it's multiplying by 3 right off the bat. So if they're all being multiplied by 3 right off the bat, it means it's kind of increasing sooner. It's happening faster. It's 3 times sooner is when it's going to take place. So if we look at this, what we'll see is that this curve will get steeper quicker, but it's also right 1 and down 3. So you can see that there. Okay? So this is really what we're after when we're talking about vertex form. So we have an idea of what's happening to the function just looking at it as it stands. So let's look at some more.
Here's two graphs then, but they've got decimals for their base, which we know means it's a decreasing function, okay, right off the bat. Well, looking at this one, looking at the value with x here, we can see that this x has a subtract 2, which means that we're going to go right 3, and then this has a subtract 3, and that means we're going to go down 3, because this is your k value again, this is your h value. And again, just referencing this here, which you'll need to memorize. Let me write that down. You'll need to memorize that so that you know where each piece actually is. The other thing that we forgot to mention here, actually two parts, we forgot to talk anything about the asymptote here, and we forgot to talk about our initial value, which are, well, the initial value anyway, comes back here, which is our y-intercept. So we should know that this thing here would be a y-intercept of 3, but you'll notice what happens here is that there's a subtract 5 that changes it. So our y-intercept isn't exactly where it's at. So barring the fact that we have it in vertex form, that is our y-intercept. If it's a little bit more basic of one that we're going to do. So going down here to finish off, we can see that we've got a y-intercept of, I wonder if I typed that in wrong. Nope. All right. So looking at here, we've got a y-intercept of 0, 1. We know that it's decreasing, went right 2, down 3, and we know that this one's already decreasing, again, because of the 0.5, but this one's increasing sooner because we have that a value multiplied in there. And so that a value is changing it. And notice our y-intercept is 4. Just like we said a minute ago, our y-intercept is adjusted by this value here because it's added to it. So it's going to change things just a bit. So just be aware of that. All right, and then finally we know that we're going up 2 because of that. So we're increasing sooner because of the a value here. And we're moving up 2 because of that value there. All right, so now you've got a pretty good idea of how this exponential function works, how it looks in vertex form, how to sketch it, and the way that it moves. So graphically, you should be pretty good right about now. So we're going to go ahead and end the notes, and I will see you in class in just a little while.